All right, welcome back to the deep dive. Our mission today is pretty specific.
Very specific.
We are tackling the infrastructure that powers these, truly massive and complex AV systems.
A really high-end residential and commercial stuff.
Exactly. We've been digging into the Blustream PRO16HBT100CS, and this is a piece of hardware that costs, what, nearly $20,000?
Around that, yeah. And its whole job is to solve the most brutal problems in video distribution.
Just to give you a sense of the scale here, we're talking 16 HDMI 2.0 inputs.
Right, and it routes those to 16 long-distance HDBaseT outputs, and at the same time, it's also managing 12 direct HDMI outputs.
That's just a staggering number of combinations.
It is a huge brain for a huge system.
Okay, so let's unpack the core challenge here. I mean, sending a 4K 60 Hz signal at full 4.4.4 color, that's an 18 gigabit per second fire hose of data.
It is. Your standard HDMI cable just gives up after a few meters.
So how does this system conquer those long runs you'd find in, say, a large building or a huge home?
So this is what's really fascinating. It uses HDBaseT technology, but it combines it with a kind of secret weapon, color space conversion. CSC.
CSC, okay.
And for you, the key thing to understand is that CSC allows that full 18 gigabit signal to be, let's say, intelligently compressed. It can travel up to 70 meters with no visible loss.
70 meters. And 1080p can go even further.
Oh, yeah, way further. Up to 100 meters for 1080p.
So for listeners who, might not be deep in the specs, why is that full 4.4.4 so important? And why is it so hard to extend?
Think of 4.4.4 as the full, raw, uncompressed image data. It's just massive.
Right.
CSC intelligently slims down just the color information, off into 4.2.0, so the signal can actually survive that long journey. It solves the distance problem without really sacrificing quality where it matters most.
Okay, so we've conquered distance, but that creates another problem. You're almost never going to have screens with the same capabilities.
That's the reality, yes. You'll have a brand new 4K panel right next to an older 1080p projector.
How does the hub deal with that? How does it avoid a total compatibility meltdown?
This is mission critical for system integrators. The system has independent automatic downscaling built right into those HDBaseT output boards.
So it's tailoring the output for each specific screen.
Exactly. It can take that huge 4K 60 Hz 4.4.4 input and on the fly, just convert it down to standard 1080p for that legacy display.
And what if a display is 4K but just can't handle the full bandwidth?
It'll knock it down to 4K 60 Hz 4.2.0. It's completely adaptive.
But wait, with all this processing happening, this converting and scaling, what about lag? Is there any kind of processing delay?
It happens almost instantly, and it's independent for each output. That level of control is, well, that's what you're paying for.
I see.
And crucially, while all this scaling is happening on the HDBaseT outputs, those 12 direct HDMI outputs, they remain a pure native pass-through. No touching the signal at all for your main displays.
Okay, let's shift gears a little, away from the video and talk about integration. This hub does way more than just switch video signals.
Oh, absolutely. The audio capabilities alone are essential.
Tell me about them.
So you have 16 analog audio inputs, which you can embed onto any video feed. So you can pair background music with the digital signage, for example.
Okay.
But the real game changer is the dedicated audio breakout board for every single zone.
That is huge, because it means you can pull the audio out and send it to a completely separate whole house amplifier system.
Exactly. You get both analog and digital SPDIF outputs. Total flexibility.
And this integration thinking extends to control, right?
It does. Redundancy is key. The hub supports bidirectional IR, so 16 inputs and 16 outputs.
Yeah.
You get full control of every source and every display.
What about making the installer's life easier?
It has PPO-C, power over cable, so it sends power to the receivers over the same CT cable as the video, less wiring. And for system control, you have everything. Front panel, RS-232, TCP/IP, a web GUI. It's designed to plug into any major control system out there.
So when you boil it all down, what does this all mean for you, the integrator or the advanced user?
Well, it means this device is, at its core, an advanced infrastructure tool.
Right. It's built to eliminate that one massive headache, compatibility. It ensures every single feed, no matter the distance or the display's age, is managed centrally and seamlessly.
And the final thought I'd leave you with is this. Look at how it's controlled. It's all managed over TCP/IP, like a piece of networking gear. So think about where high-end AV is going. These systems are behaving less like old-school video splitters and really more like highly specialized network switches designed for just massive data throughput and complex real-time tasks.
An AV matrix that thinks like a network switch.
That's the evolution. That's where the whole industry is heading.